Welcome to the first in a series of videos I'm creating about web components. I want to begin by walking through a simple example of a web page that implements some functionality that we will later implement using web components. You can see on the right that I'm implementing a simple counter. I can click the plus button to add and the minus button to subtract, and when I get down to 0, that decrement button gets disabled. So taking a peek at the code, I just have a single HTML file, and if I scroll to the bottom and look at the HTML, we see that there's just a label that says score, and I have a decrement button and an increment button. The decrement button starts out being disabled, and the value of the counter starts out as 0 inside the span element. Scrolling up to the top and taking a peek at the CSS, I'm making the label bold. The decrement and increment buttons have a background color of light green, and then any button that becomes disabled has an opacity of 0.8. The most important part here is this script, and when the document is loaded in the browser, I want to find the decrement button, find the increment button, find the span, and now I can operate on those. I start the count at 0, and then I add a click event listener to the decrement button. When that's clicked, I want to subtract 1 from the count, and then I update the text that is inside the span. If the count reaches 0, then I want to add the disabled attribute to the decrement button. The increment button event listener is similar, but in that case I want to add 1 to the count. Again, update the text content in the span, and then I know the decrement button should no longer be disabled if I have added 1, and so I'll remove the disabled attribute. So all that's fairly straightforward, but we do have an issue if I want to have 2 of these counter components on the same page. And so skipping over to the next bit of code, this is the same thing implemented in a single web page, but the HTML has changed a bit because now I have 2 of those counter components. One has an ID of level, the other has an ID of score, and then I have the same kind of content inside them as we saw before. Looking at the CSS at the top, that's identical to what we had. But now the difference is that when I set up the event listeners, I'll need to do it separately for each of the instances that I have at the bottom. And so I have this function wire counter, and you see 2 calls to that down here on lines 35 and 36, where I'm passing in the name of the property that I want to update when the counter value changes. And so up in the wire counter function, I get that ID, and I can find an element that has that ID. And we see at the bottom I've got a div with an ID of level and another one with an ID of score. Once I have that, I can use that as my basis for finding the things inside it. And so I'm using query selector and calling that on the counter to find the decrement button, the increment button, and the span element. And now I can wire up the event listeners similar to before, but this time I need to tell it which one of the values I'm incrementing or decrementing. And you see here on line 34, I've got this data object with 2 properties, level and score, and those are the names I was passing to wire counter. And so I can decrement the correct one and then update its text content. And like before, when the count reaches 0, I want to disable the decrement button. The increment obviously adds 1 to the value of that property and updates the text content in the span, and then removes the disabled attribute. And so coming over to here, I want to change this and show you that page. And so let's go to the end of this URL, stretch this out so I can see it, and then change counter 1 to counter 2. And now we have 2 of those, and they have the correct labels, and I can increment, and it doesn't change the value of the other one. And if I go down to 0, it becomes disabled. Okay, so that's great. We've got this implemented in a fairly concise way. I've got this function that sets things up separately for each of the counters, but still, this is a lot of code, and I've duplicated the HTML here. So we want to look at a way that we can avoid that by using a web component. So here's the third version of our web page. And here I'm pulling in a separate JavaScript file, countervanilla.js, and then I'm using this as a web component. So my web component has a name that has a dash inside it. That's a rule of web components to distinguish those custom elements from the built-in HTML elements. And I'm passing it the attributes for the label and the count. So my level starts with a value of 1, and my score starts with a value of 0. And now we want to check out this JavaScript file that defines our web component. So over here, it's common for web components to begin by defining a template element that holds all the HTML that you plan to render. And this is good because you'll only parse the HTML one time and hold on to that, and then for each instance of the web component, we'll just make a clone of the content of that template. So what you see inside the template here looks pretty similar to what we saw before, but I have a label with nothing inside it yet, and I have a span with nothing inside it yet, and I have the decrement and increment buttons, but they're not wired up to do anything just yet. The CSS is identical. Now you might be curious why I have this tagged template literal here with HTML in front of it. And I'm defining HTML right here, and it's just a raw version of a tagged template literal, which basically means that it's not doing any processing for us. The only reason that's there is that I want VS Code, my editor, to be able to provide formatting of this content and syntax highlighting the way that you see here. And so the VS Code extensions I'm using are Prettier and ES6 string HTML. So I highly recommend those, and if you're using a different editor, there's probably extensions for your editor that do similar things. But again, that's the only reason why I have this tag HTML in front of my template literal string. And of course, the template literal string is allowing me to have multiple lines of content in that string. All right, so coming down to the class definition of counter vanilla, and you see that this extends the class HTML element. So that's a basic thing that you do when you're defining a web component. Then jumping down to the constructor, I need to call the superclass constructor, which is HTML element first. And then I'm attaching a shadow root here. So that attach shadow is allowing me to use the shadow DOM. And there's two modes for this. It can be open or closed. It's most common to use open, and I'll talk about the differences between open and closed a bit later. This attribute changed callback is going to be invoked anytime an attribute of my custom element changes. And jumping back to the HTML, we see that I have two of those. I've got label and count. And so if those change, I want to react to that. But this will only be called for attributes that you said you want to observe. And that's what I'm specifying up here in this static getter observed attributes, that I only want to watch the count attribute. And so whenever that happens, I'm making sure that I have a reference to the span that's inside the web component. And if I do, I'm calling the private update method, which is going to update the text content inside that span. And the reason I'm checking to see if I have the span is that attribute change callback actually gets called before it has finished building the DOM, and so I don't necessarily have that yet. Connected callback is going to be called after my web component instance is added into the DOM, and at that point I can start I can add content to my web component. And so because I'm using shadow DOM in open mode, I do have access to this property shadow root on the current object. And so I'm putting that in the variable root because I'm going to reference that multiple times throughout this method. Next, I can locate the label that is inside my web component and set its text content to be the attribute label that was specified. And we see that over here, label equals level, label equals level, and label equals score. Okay. Next, I want to locate the decrement button, and I want to add an event listener to it. And this is similar to the JavaScript code that we saw earlier. However, Instead of actually doing the work here, I'm calling a method in this class. And the reason I'm doing that is that I might get a reference to this web component in other JavaScript code and want to change the counter by calling the decrement and increment methods on it. And that's why I've implemented those as methods. Similarly, I'm finding the increment button and adding a click listener on that. And the reason that I'm holding on to dec button as a separate property, but I'm not doing that for inc button, is that I need to be able to disable the decrement button when the count reaches 0, but I'll never need to access inc button outside of this method. Next, I'm holding on to the span element, and I need that inside this update method. So jumping down to the update method, we see that I'm going to the count attribute, and I'm going to use that as the value that I place inside the text content of the span. And if the count has reached 0, I want to disable the decrement button, but if it's not 0, I want to remove that attribute. Okay, taking a peek at the decrement and increment methods, they work similar to before, but every time I decrement or increment, I want to call update, which, as we saw, just updates the span and properly decides whether the decrement button should be disabled. I do have getter and setter methods for the count, and again, that is so that if I get if I have a reference to this web component instance from other JavaScript code, I can retrieve the value of the count, and I can change it just by setting it directly with an assignment to that property. So one thing you could say about this implementation of a web component is that I'm treating the count attribute as the source of truth to know what the value of it is currently. There are other approaches you could use. You could say that a property called count is the source of truth, and when that changes, then I'll update the attribute. But here we're going in the opposite direction and treating the attribute as the source of truth. So we have this web component defined. We're using 2 instances of it here. And so now I want to come over to the browser and change to look at that implementation. So I'll change counter 2 to counter 3 and zoom in a bit. And this looks the same as what we saw before. That's our goal, is to just re-implement that functionality but using a web component. And so I can click on the buttons and it works as we hoped. So what do we think about this implementation of a web component? Well, if you think about how you might implement this using some other web framework like Angular or React or Svelte or Vue, surely the code would be much more compact than what you're seeing here. Now, there are other approaches we could take to use web components and make the code more compact. One of those approaches is to use a library called lit.